known as a right-handed coordinate system. I cross j is k, j cross k is I, k cross I is equal to j. In other words, I, j, k, and we just rewrite that, I, j. If I'm going in this direction, it's positive, so I cross j is k, j cross k is I, k cross I is j. If I'm going, those are positive. If I go this direction, I'll get a negative. K cross j is negative I. Or k cross j is up, and down we established as positive. All right, what is the direction of the torque?
Positive I hat.
It will be perpendicular to the two vectors and multiplying. So that's 3 newtons I hat. This is 2 meters j hat. So I have 2 meters j hat across 3 newtons I hat. So multiply those, I get 6 newton meters. Now I've got j hat cross I hat. J cross I
Is K.
I'm going to the left.
Negative K.
So negative 6 Newton meters K hat. You can also think about it this way. If I had a door here, if I had or any beam, and that's my axis of rotation, if I push on it like that, it's going to cause it to rotate around clockwise. Clockwise rotation into the board. And for those who came in a little late, you might have missed that whole right-hand rule, so you can check well, I have a pre-made video as well as the beginner class where I talk about right-hand rule and determining the direction of rotating things. Questions to hear? All right, so if R and F, if the lever arm or moment arm and the force are perpendicular, you just multiply them out and then you can use right-hand rule to determine the direction. If they're not perpendicular to each other, I'm just going to do this conceptually. So if my door is like this, I apply a force upwards, there's my force, my moment arm, they're not perpendicular to each other. Then what I need to do is figure out how much of the force is perpendicular, how much of the force is parallel. Because the parallel part's not doing anything to get it to turn. It's only the part that's perpendicular that gets it to turn. So we break force up into its parts. That's the part that you would actually multiply. A 5-second aside, the magnitude of the torque, more than 5 seconds apparently. Magnitude of the torque would be the magnitude of R times the magnitude of F times the sine of the angle between them when they're tail to tail. If you've never had trig, don't worry about it, it's just an aside. Now, for the lab that we're going to do, and fortunately the earlier class had already done it, so the setups are almost, everything's out already put together. If the meter stick, think back to the second lab, if the meter stick is horizontal and the force is down, then the moment arm and the force are perpendicular to each other. Now, if the meter stick, again, thinking back to that second lab, you had the meter stick there, all you were concerned about with forces, now we're gonna do it concerning torques. So you want the meter stick to be as horizontal as possible because we're dealing with weights and strings holding it up, and you want them all to be as perpendicular as possible so that the math is a lot easier. I know that the total torque is equal to I times alpha. Well, if this is not rotating, what is alpha? It's not rotating at all, just sitting there.
0.
So if in rotational equilibrium, the total G2 Kubuka is equal to 0. And that would be, see, this is kilogram meters squared times radians per second squared. Oh, Newton meters. One comment about the units. When we're talking about work and energy, a Newton meter is a joule. When we're talking about torque, a Newton meter is not a joule. It's Newton meter, there's no one word representation for the units for torque. It's only a joule when talking about work and energy. So if I have, let's say this is 3 newtons, 5 newtons, and 8 newtons. We'll assume that the meter stick is massless for right now. If that is 0.1 meters and that is 0.8 meters, where is this one so that it is in rotational equilibrium? Well, I know the total torque is 0. My moment arms are perpendicular to my forces. So what I'm going to do here is, if I treat that as my axis of rotation, if I have this meter stick here and it's going to pivot about this point, this 3 newtons is going to cause it to rotate which way? Clockwise or counterclockwise? Counterclockwise. Out of the board. So if I make those positive directions, I hat and J hat, K hat's coming out. That's an I. Wow. So I have positive 0.3 Newton meters. Now this one right here, my 5 Newton, that's 0.8 meters away. First off, what is the magnitude of the torque about that point caused by that force?
That's 0.8, no?
Yes, that's 0.8, and 0.8 meters and 5 newtons.
4 Newton meters.
It's causing it to rotate clockwise. And then this one right here, I don't know what it is, but I do know it's going to be 8 times whatever x is. Equals 0. So I have 4.3 minus 8x is equal to 0. That's the math problem. X is how far it is from the left end. Let me get this over to this side by undoing it. So we add 4.3 is equal to 8x. I'm trying to solve for x, so let's get rid of the 8. X is whatever 4.3 over 8 is. Which is
0.53. .54,
5375?
yeah.
So that's where that has to be in rotational equilibrium. A little over halfway down the meter stick. In lab 2, if you got the 4 scales backwards, there was some penalty there, but there wasn't a whole lot of an effect other than it was a nuisance. But now if you get the 4 scales backwards, it can have a big impact on your analysis. In the lab, I ask you to choose, there are various different points you can pick where the axis of rotation is. If it's just sitting there, if it's in rotational equilibrium and not spinning, so static rotational equilibrium, then you can pick a pivot point anywhere. Pivot point doesn't even have to be on the meter stick. It can be someplace else. If it's not rotating about any point. The last analysis question is a bonus quiz grade. It's a full entire quiz grade. Because this is an actual experiment, I'm not expecting the total torques to actually be 0. They should be close to 0, but not exactly 0. The last analysis question says, where would you put assuming all your force measurements are correct, where would you put the axis of rotation to get the least amount of torque possible? There are math ways of doing it. My spreadsheet I've set up is brute force. I try loads of combinations. But anyway, so when you see that there's an optional last analysis question, which again, if you do it, you potentially get a full lab grade. And the way it counts is that if it helps you, if you do it, and you get an A, it's going to help you. If you do it and it helps you, I'll count it. If you do it and it doesn't help you, I'm not going to count it. And whether it helps you or not, I'll know at the very end. Unless, of course, it's an A, and then that won't hurt you. Because I don't think anyone here is straight A pluses on every lab. Questions to hear? All right, I'm about to shift gears and talk about the tests. When we're in lab, I'll tie back the tests. There will be test corrections. The rules for test corrections. You're trying to convince me that you understand. If you just put an answer down, that tells me nothing. Just putting the correct answer down gets you nothing. You need to work through the problem, or explain why, or somehow justify. Just putting down the correct answer is not enough. Corrections on separate paper. It's in one of the videos, but I'm going to rehash it. The student who did all the corrections on the original test in the original colored ink, and now you have to go through and try to figure out, all right, what's correction and what was the original work. He did not get the benefit of the doubt. So, separate paper, so I know this is your correction for this problem. If you failed it, which I don't think any of you did, you can bring it up to a C. So let's set that chart up. So if you got an F on it, which is a 0.0, you can bring that up to a C, which is a 2.0. If you got an A on it, which is a 4.0, you can bring that up to an A+, which is a 4.3. That sets up the scale. It's just a linear relationship. If you got a C on it, which is a 2.0, you can bring that up. Well, that's halfway between 0 and 4, so it's halfway between 2 and 4.3, so you can bring that up to 3.15.
This would be the maximum you can get back. Here are the issues well, first off, before we get to the issues. Typically, people up here don't get full credit because it's not worth their effort. They'll hit low-hanging fruit and stop there. People down here generally have so much that they don't understand that it's difficult to get it up to the full credit, but it has been done. The biggest issue I've had with 110 students doing corrections is the number of papers I get handed in, number of correction papers I get handed in with only the answer. Actually, it's a problem with the test too, but at least potentially you get something for it on a test. But please, I need to see your work. It is okay to get help from other people. Just as a warning, and I've seen this before, I had 2 people handed in with the corrections which were identical. Space for space, mistake for mistake, et cetera, et cetera. And that tells me I don't think either of them understand it. So it needs to look like your work. Again, you're trying to convince me that you understand.
So do you just want us to explain like where we went wrong?
All right, so on that matter, I don't require it, but I have found that for students who start out with, this is the way I got it wrong, and here's what I should have done, and here's the correct answer, I tend to look more favorably upon those. So I would recommend it, but it's not required. I've had students not do it, and they still do very, very nicely. Now, let's say that you got a C on it, and you bring it up to maximum credit to a 3.15, which is a high B or a low B plus. It would go in the grade book as 3.15. I'm not gonna round it off to, well, it's close to a B, so I'm gonna make it a 3. It'll go in as whatever decimal. I think I go 2 decimal places. Actually, probably on my spreadsheet I go however many decimal places it is. What would show up in Blackboard would be 2 decimal places. I think they do too. We'll find out. All right, so in lab, I'll hand those back as well as anything else that I have floating around. The lab is underneath the table.